Imagine walking through a bustling Singapore street, where conversations flip seamlessly between English, Mandarin, Tamil, and Malay. This linguistic mosaic, called code switching, is common, but it's a nightmare for speech recognition systems. Traditional AI models struggle here because they're trained on clean, single-language data. But what if we could teach them to handle this real-world complexity without needing hours of messy, hard-to-collect code-switched recordings? That's exactly what this study achieved. Researchers discovered that high-performing speech recognition systems can be trained using synthetic data, computer-generated speech that mimics real code-switching patterns. Instead of relying on rare, annotated real-world examples, they created fake but realistic language mixes, then tested them on new benchmarks tailored to Singapore's linguistic landscape. Let's break down the problem first. Code switching isn't random, it's a structured, context-driven phenomenon. For instance, a Singaporean speaker might say, "I need to go to the Kedai shop, but I'm so tired, man." Traditional ASR systems, trained on monolingual data, can't parse this. They either misidentify the Malay word, Kedai, or fail to recognize the English man as an interjection. This creates errors that can exceed 100% word error rate, WER in some cases. The solution? Phrase-level mixing. Instead of randomly swapping words between languages, the team blended entire phrases. Think of it like remixing two songs at the chorus, natural, seamless, and true to how people actually speak. They used tools like Google Translate to generate bilingual transcripts, then spliced monolingual audio clips to create hybrid sentences. For example, a Mandarin sentence might transition to Malay mid-sentence, with AI like ChatGPT generating fake dialogues to add authenticity. Here's the technical kicker: they didn't just create random mixes. They analyzed real-world code-switching patterns to ensure linguistic consistency. For Malay-English pairs, they preserved intonation and stress patterns. For Tamil English, they maintained phonetic overlaps. This attention to detail made the synthetic data indistinguishable from real speech in some cases. The results? Massive improvements. When tested on models like Whisper and Seamless M4T, the synthetic data reduced WER by up to 83% for Malay-English switches and 44% for Mandarin English. Even Tamil English, where code switching often occurs at the sentence level, saw significant gains. The key was training on mixed language corpora, rather than relying on monolingual data. But why does this matter? Many languages, especially in regions like Southeast Asia, lack the vast datasets needed for AI training. This method is scalable, cost-effective, and a game-changer for under-resourced languages. It's not just about better tech. It's about respecting and supporting the rich, blended cultures that define places like Singapore. Here's the deeper implication. Code-switched data isn't just helpful, it's essential. It helps models recognize real-world speech patterns and reduces biases. For example, models trained on synthetic data showed 75% fewer errors in detecting Malay and English contexts. This opens doors for more inclusive AI in translation, customer service, and accessibility tools. So what's next? The researchers plan to refine synthetic datasets by incorporating natural speech rhythms, grammar rules, and regional dialects. They're also expanding benchmarks to include more languages from Southeast Asia. Next time you hear a voice assistant struggle with a multilingual conversation, remember, scientists are hard at work turning today's challenges into tomorrow's breakthroughs. Thanks for watching. Stay curious.